Let's take a look at 2025 question 10a. So what we have here is we've got something to tell us a story, who cares? It's a difference equation, and we can see here there's a little bit added on here, and this little bit means it's something like an plus b. Okay, so two things together, which means that it's a linear. Okay, so that's gonna be relevant in a while. But first, he tells us that in S0 is 2016, and then 1 month the company has 3,500, so S1 is this. Write down the values of S2 and S3. So looking at your equation, can you replace the n's with zeros? Because that would make, if I put n as 0 here, that would make this part S2, which is what they're looking for. So replace your n's with zeros. So I'm going to say s by 0 plus 1 plus 5 by s0 minus 15 by 0 plus 40. I'm going to plug it all in. So S2 is a quarter of S1, which they told us was 3,500, plus 5 times 2016, minus 0 plus 40. And when I plug in my calculator, here's what I did earlier, I get 3435. Okay, so that's the first part for finding S2. You're going to rinse and repeat this idea to find S3, so we'll go ahead and do that. So rinse and repeat that idea. I'm going to say S3 is 1 plus 2, where I'm letting n equal 1 this time. So here this becomes S of 1 plus 1 plus 5 times S1 minus 15 times 1 plus 40. Plug that in. S3 is going to be a quarter times S2, the thing we just found, plus 5 times S1, which is given in the question as 3,500, minus 15 plus 40. And having looked through there, I plug it in my calculator, and again, sometimes I went ahead and did this, or I just paused the thing and then did it, because I don't want you to just wait for me to clippy clap type things. We get to that guy there, where we get S2 and S3 as follows. Just in terms of the mark scheme, 5 marks going for getting both of them in that one there. Right, let's take a look at part 2. Okay, so let's take a look at part 2. So in part 2, they're asking us to solve the difference equation to find an equation for Sn in terms of n. So to get our difference equation, we're going to need to have the homogeneous part plus the particular solution. Okay, so for the homogeneous part, what I'm going to say here is just ignore the linear part of this equation and just focus in on this part. Reminding ourselves that we can replace this with lambda squared, Sn plus 1 with lambda, and Sn with nothing. So I'm going to do that straight away. I'm going to say, okay, lambda squared equals a quarter lambda plus 5. Now, to make my life easy, I'm going to multiply everything by 4 and then bring everything to the one side. Just be careful of your signs when you bring it over. This becomes a minus 5, and all of that equals 0. Okay, so then what I look at here is going, can we factorize this? And when I factorize this, I'm going to have lambda plus 1 by 4 lambda minus 5. So I get lambda equals to negative 1, or 4 lambda equals 5, lambda equals 5 over 4. So we have 2 different solutions, which is fine, perfect. So let's make our homogeneous equation from this. So from this, we're going to make our homogeneous equation, and it's going to be Sn, I'll call it H for homogeneous, is going to be, they're both different, so it's going to be alpha times minus 1 to the n plus beta times 5 over 4 to the n. Okay, and that's the very first part of our problem there, kind of solved. So always getting the homogeneous solution first. I'm actually going to throw it down there just for a bit of space saving. Now, for this next part of finding the particular solution, right? What we tend to go for is we say, okay, well, take a look at the equation again. It was a linear, so it should look something like that there, an plus b. Now, sometimes you'll see, right, where you might have been told about the multiplicity, where you maybe multiply it by n, right? or n to the power of m, where the multiplicity is how many times it's repeated. But in this case, there's no repeated root, so there'd be just n. But also, we're actually not going to do it by n here, just for clearing that up, because neither of the roots are 1. You only do it by n if the roots are 1. So in this case, we can actually just take our guess as an plus b. So now I'm going to say, let me write out what n plus 1 is. N plus 1 plus b, an plus a plus b. And I like to write out the second one as well. You don't have to do this here. I just find I tend to make less mistakes if I do it here. Just once it gets to the next, it gets very big and complicated. So I have Sn plus 2, Sn plus 1, and Sn. Now go up to your equation, shwink, and what you're going to do is you're going to get all this stuff on the left-hand side. So get that over to the left, and let it equal the side there. So I'll do it on the next page here. And I'll do it from scratch just so you can see it through. So Sn plus 2 equals a quarter Sn plus 1 plus 5 Sn minus 15n plus 60 plus 40. So now in our next instance, what we're going to do is we're going to bring everything over to the other side. So I'll clean it up before I plug stuff in. You can do whichever you want though. Obviously, it's your thing to rearrange. Plus 5Sn equals equals minus 15n plus 40. I'm going to multiply everything by 4. So I get 4Sn plus 2 minus Sn plus 1 minus 5Sn equals minus 60n plus 160. And now I'm going to substitute in these guys I had previously for Sn plus 2. So I'm going to copy that. Obviously you can just, write it, but I'm going to copy paste because I have the power and the technology. I'll get the other one as well on here. Copy that guy for Sn plus 1. Move them down here. So what I'm going to do here is I'm going to say, okay, 4 times this one here minus all of this stuff in Sn plus 1 minus 5 times an plus b should all equal minus 60n plus 160. Now, in my next instance, I'm going to multiply this out. Minus an minus a minus b equals, minus 5an minus 5b all equals this side over here. And we're kind of getting to the last legs now. What I'm going to do is, you can add stuff if you want, but I'm not going to bother, it's a lot of work. I'm instead going to say, okay, I'll underline in red anything with an n. I'm going to let the left hand side equal the right hand side. But I'm just going to take out anything. So I like to use Mario and Luigi. Mario, Mario, he collects the n's, so he's going to say 4a here, minus a, minus 5a should all equal minus 60. I've just removed all the n's there, but he's collecting the n's on the left and right. Simplifying that down, I'm going to get to 4a minus a is 3a, minus 5a is minus 2a equals minus 60. That makes it a equals 30. Let's just see what Luigi gets up to. So Luigi is going to collect the constants. That's anything without an n. So in this case, I'll do him in blue. He's going to collect the a's, the b's, the a's, the b's, the b's, and the 160. So here I'm going to say 8a plus 4b minus a minus b minus 5b all equals 160. And you can neaten that up beforehand if you're so inclined, but it doesn't really matter because math is math. 7a, 4a minus a is 3a, so minus 2b equals 160. 7 by 30 minus 2b is 160. So I end up getting minus 2b equals 160 minus 210. Don't trust myself with the maths today, is minus 50, so I get b is 25. Finally, getting to the end here, what we want to do at the very end here is we want to put it all together to make ourselves a lovely equation. So what I'm going to do here is I'm going to say, okay, now that I've got my a and b, let's go back up here and get our homogeneous solution that we had earlier. Copy that guy. And we're going to add on the particular solution. So over here, I'll just cover that up there. And I'm going to add in the particular solution. So I'm going to say it's the homogeneous solution plus the particular solution. And my particular solution here, what is my particular solution? Well, if you go back up here, it was AN plus B. So it's going to be 30N plus B here, which is 25. So 30N plus 25. I'm just going to get rid of that one. Bring them closer together. Sorry, just 25 there at the end. Now, I have the luxury here of the power of technology to shrink all my writing, but you can see like it takes up a lot of space, this question, and I'm not actually done yet, because now I need to go back to the beginning and sub it in to get my other answers. So I'm going to say S0 is 2016. So let's plug this in here to find alpha and beta. So 2016 is equal to alpha times n to the power of 0 just makes this whole thing 1, so it's just 1. This, the power of 0, makes it also 1, so this just becomes beta. 30 to the power of 0 is nothing, plus 25. So we end up getting 2016 minus 25. I get 1991 is alpha plus beta. That's one of my simultaneous equations. Now rinse and repeat with S1. So I'm going to plug S1 in, so go back up to the question, and it was 3,500. So plug 3,500 in for S1. This is now minus 1 to the power of 1, which is minus 1, so this becomes minus alpha. And this becomes 5 over 4 to the power of 1, so that becomes plus 5 over 4 beta, plus 30 plus 25. And again, let's move the 30 and 25 over to the other side. So now minus 30, minus 25. So I get over here on the right, 3, 4, 4, 5 equals minus alpha plus 5 over 4 beta. And that's my second simultaneous equation. I'm going to just add these bad boys together. So I'm going to say, okay, U, copy U, and paste them down here. And what I'm going to do is I'm going to say, okay, if I add these two together, then what I eventually get is 3, 4, 4, 5 plus 1, 9, 9, 1 equals 5, 4, 3, 6. The alphas cancel, and I say 1 plus 5 over 4 is 9 over 4 beta. Making beta the subject, so 5, 4, 3, 6 multiplied by 4 and divided by 9, I get beta to be 2, 4, 1, 6, which is perfect. Now, go back and find alpha, so go up into either equation. Equals alpha plus beta. 1991 equals alpha plus 2416, so alpha is 1991 minus my answer, minus 425. Yikes, I'm so tired. And then I go, okay, over to here, grab this guy, copy pasta, bink, drop him down here, and replace in your alpha and beta with your new alpha and beta. And I'm just going to do that cheekily here with the power of technology. So I'm going to go minus 425 and 2416. Obviously you can be neater than Steve, and don't forget at the end of the exam you can use extra paper, don't hesitate. But there it is in full, in all its glorious, glorious violence. Now, there's a lot of marks to pick up there. There's 25 marks actually going in this section. So just having a brief look of where the marks go, okay? First off, if you get your two solutions, that's 5 marks, okay? If you manage to get down to creating or identifying the particular one here, that's 5. And then if you create your equation correctly, so sub it in correctly. Now, you're not really getting the marks for the rearranging here, but you are getting it once you sub it in on the next line. So I still think the rearrangement is needed. I would make a lot of mistakes if I didn't rearrange it, but you're probably better than Steve. So that's always the important thing. 5 if you get A and B, and then 5 for your final answer at the end. Okay, so a lot of work, but you can kind of see like I could have maybe been a bit smarter with space earlier. Okay, that's it for part 2. Part 3. The strategy is deemed successful if the service has at least 35,000 customers after 1 year. Is this strategy successful? Justify your answer. Now, the thing about this one is, you know you're just going to plug it into this equation, but you need to know what are you plugging in. So I'm just going to copy paste that equation. Okay, but I need to have a check and read the question carefully and watch for any little tricks the examiner might have. And the big trick is it says 1 year. So a lot of people will plug in the number 1, but we go back up here and we have to check. After 1 month, the company had this many customers. So what I need to do is not plug in the number 1, but in fact plug in the number 12, because there are 12 months in the year. Minus 425 by negative 112 plus 2416, 5 over 4 to the power of 12 plus 30 by 12 plus 25. And if you plug that all in your calculator, what you end up getting is 35117. So make sure to answer the question, is it successful? Yes. Strategy works. Works as it's over 35,000 customers. Give a big smiley face, and that's you getting another 5 marks there, making this total question worth 5, 25 and 5, so 35 marks going for that question A part. Okay, nice little linear one. What to watch for, and to reiterate it, is this guy here. Take your first guess at a linear. I would generally, if one of these is 1, I would always multiply it by n to the power of 1, and if they were the same root repeated, I would multiply it by n to the power of 2, and so on. But generally always try that as a first guess, will get you probably to your answer. Okay, let's look at question 10, part B. So we have a projectile as being particles projected from point P at initial speed u. We don't know the angle, so I'll call it theta. And after 6 seconds, its horizontal displacement and vertical displacement are 75 and 30 respectively. So the horizontal is 75 and the vertical is 30. Okay, so let me just break it into its components first. So I'm going to break it this way. That is u cosine theta. I'm going to break it up this way into its vertical. That's u sine theta. So what I'm going to say is do your components in the x direction and the y direction. So in the x direction, or in the I direction, whichever way you like to talk about it, I'm going to say that my S, my distance in the X, so just be careful, horizontal displacement is 75. My time is 6 seconds, and my speed, my velocity is u cosine theta. So I end up getting 75 equals 6 u cos theta. Distance equals velocity, speed by time. You can simplify that. Let's divide that by 6. Is it a nice number? Yeah, I'll say it's, I'm actually going to rearrange it to say u equals 12.5 over cos theta. Maybe you might need to get cos theta alone, but look, sure, we'll put it like that for now and see what happens. Next one, let's do the y direction. So in my y direction, I'm going to say here, okay, my uvast, U-V-A-S-T. So my initial velocity in the y direction is u sine theta. My final velocity I don't know because it hasn't told me it's the max height. I do know the acceleration is minus 9.8 and the distance was 30 meters in a time of 6 seconds. So going back to here, I'm going to say which equation has UAST, and that's S equals UT plus a half AT squared. So I say 30 equals U by T, so 6U sine theta, plus a half by minus 9.8 by 6 squared. 6U sine theta. And grab your calculator, do that multiplied out, and I get it to be minus 176.4. I'm going to move that over to the left hand side and I get 206.4 equals 6u sine theta. Divide both sides by 6, I get 34.4 equals u sine theta. I'll make u the subject. How do I get you alone? And there I go. I've got two equations with u. So I've got this one over here, and I've got this one. And you've guessed it, let them equal each other. So I'm going to say 12.5 over cos theta should equal 34.4 over sine theta. Now I'm going to multiply both sides by sine theta. So I'm going to say 12.5 sine theta over cos theta equals 34.4, and then I'm going to divide both sides by 12.5. Just going to see if it's a nice number. Oh yeah, it's okay, fine. So it's 2.752. Now, sine theta over cos theta, if you check your formula booklet on page 13, you'll see that becomes tan theta. And now we're kind of done. You can find the angle if you like, it's perfectly fine too. I'm actually going to be a bit kind of smart about this, and I'm just going to put it as the angle is this, the tan inverse of whatever that number is. Just checking my calculator what it is. If you put it in and continue, you'll be fine. Just give yourself a good few decimal places. So it's about 70, bang on. But I'm going to leave it like that just to show that it doesn't matter. If I go up here, u equals 12.5 over cos theta, because that's what he was asking for in the exam, or they were asking for. I'm going to say, instead of cos theta here, I'm going to say cos of tan inverse of 2.752. And what you should find is, if you use your calculator correctly, is that actually you'll be totally fine in plugging that all in at once into your calculator. So I'm going to do that just now, get an answer for you. Also, I'd recommend in a question like this, when you're tucking away into it, especially when you get down to something like this, the end, you can actually check your answers correct, which is quite nice. 2.752. Close off my brackets. That looks good. And I get it to be 36.6 meters per second. I'm just going to rinse and repeat with the other one. 34.4 over sine, and again, sine of all that stuff there. So duplicate that, bring it down there. Unfortunately, you don't have you just use this in an exam. It'd be much handier than writing. Game over for me if I was writing it. This is going to be, delete that sine of that, and on top it's 34.4. And you should find, if math works out well for you, yay, that you get the exact same answer. Ooh, happy day. And what a nice question to finish off the 2025 higher level exam.